Is the filter behind us or in front of us?
I mean, that is literally the single most terrifying, heavy question you could possibly ask about our existence. It is the ultimate existential trap.
Right, because I want you, the listener, to imagine you are walking through this vast, incredibly ancient, pristine forest. The trees are towering, the ecosystem looks perfectly intact.
Yeah.
But as you walk deeper, you slowly realize something horrifying. There are no animal sounds at all. No birds, no insects, no rustling in the bushes. Just absolute dead silence.
And that creeping dread sets in.
Exactly. You realize that either nothing ever lived here or something came through and wiped every single thing out.
And that is the exact reality of the night sky. I mean, the universe is incomprehensibly old. We're talking billions of years older than our own solar system, and it is vast beyond human comprehension.
And mathematically, it should be full of life.
It should be absolutely teeming with it, ancient galaxy-spanning civilizations, and yet there is just the great silence. We look out and we hear absolutely nothing.
No radio signals.
No megastructures, no heat signatures of industry, just static. This is the great filter. The idea that somewhere along the evolutionary timeline of the universe there is a barrier, a step so incredibly difficult or a trap so utterly lethal that it just eliminates almost all forms of life.
Which means we face a terrifying binary choice. The filter is either behind us or in front of us.
Right.
If it's behind us, it means we survive something that almost nothing else in the universe ever survives. It means the very act of life starting, the past filter is a mathematical miracle.
Yeah, if you look back at Earth's history, for 2 billion years, life was just boring, single-celled bacteria, just floating around, doing absolutely nothing complex.
Just a static slime.
Exactly.
Yeah.
And then one freak accident happened. One cell swallowed another and didn't digest it, creating complex cells.
Yeah.
Eukaryogenesis.
And the entropic barrier to building a complex cell from scratch is, it's effectively like rolling a billion dice and having every single one of them come up as 6. So simultaneously.
And it's not even just the biological hurdle, it's the planetary conditions required to even allow those dice to be rolled over billions of years. Think about the moon.
Oh, right, the gravitational anchor.
Right. Without our massive, disproportionately huge moon acting as a stabilizer, Earth's axis would wobble chaotically. We are constantly mapping these wildly tilted planets out there, completely unstable worlds, where the climate swings so violently that complex life could never, ever take root.
So the stability you experience right now sitting and listening to this is an extreme anomaly.
Yeah. So if the filter is behind us, the silence is explained by the fact that we are a freak occurrence. We're utterly, completely alone.
But the alternative is, it's so much worse. The future filter. The idea that actually life is super easy to start. Planets with bacteria are everywhere.
The rapid start idea?
Right. But the reason the universe is silent is because something inevitably kills civilizations before they can spread across the stars. This is the bad news argument.
Which is horrifying.
It is. It means that if we ever dig a hole on Mars and find a fossil of a complex organism, it would be the worst headline in human history.
Because if life is common, then the great filter is still waiting for us. It means that civilizations inevitably hit a technological cliff.
Like artificial intelligence.
AI, maybe nuclear annihilation, maybe something we haven't even conceived of yet. But it implies that within a few hundred years of inventing radio, a species almost inevitably destroys itself. We are trapped in this binary choice. It's either unbearable loneliness or inevitable doom.
So today, we're going to try and figure out which side of that coin we are on. We are looking at a massive amount of recent astrophysics data, quantum mechanics models, reports on organoid intelligence, just to map out this terrifying cosmic cage we are trapped in.
It's a lot to cover.
It is. And we are starting with the deeply unsettling fact that our reality is physically being torn apart.
Yeah, because the night sky feels static to us, but it's a total illusion. The universe isn't just expanding, that expansion is accelerating. Roughly 9 billion years after the Big Bang, this repulsive force began to overpower gravity on a cosmic scale. Dark energy. It makes up about 70% of the total mass energy content of the universe, and it is actively stretching the vacuum of space itself.
See, we have this human tendency to think of space as an empty room, just a big dark room where planets and stars sit.
Yeah.
But what you were saying is the room itself is expanding.
Exactly.
It's like you were standing in a hallway, and the walls are constantly moving further away from you at an accelerating speed, so no matter how fast you run, you can never, ever reach them.
That is a brilliant way to visualize it, and we are currently watching those walls move with a level of precision that is honestly breathtaking. We have mapped roughly 1/8 of the entire sky over the last few years, looking at the distribution of matter over the last 6 billion years.
But mapping this has exposed a really persistent nagging problem, right? The Hubble tension.
The Hubble tension, yes.
I want to spend a second on this because it sounds like a dry academic debate, but it's actually a crisis in our understanding of reality. We are trying to measure exactly how fast those walls are moving away, the Hubble constant. But our rulers just don't agree.
They wildly disagree. We essentially have two ways to measure the expansion of the universe. The first way is to look at the very early universe. We measure the cosmic microwave background, that's the leftover radiation from the Big Bang.
The baby pictures of the universe.
Exactly. By looking at the tiny temperature fluctuations in that ancient light, we can use the standard model of cosmology to predict exactly how fast the universe should be expanding today.
Okay, so that is method A, looking at the past and projecting forward. What is method B?
Method B is looking at the local universe right now. We use what we call standard candles. These are specific types of stars like Cepheid variables or type Ia supernovae that have a known consistent brightness.
Because we know exactly how bright they're supposed to be, right?
Yeah. Right, so we can look at how dim they appear from Earth and calculate exactly how far away they are. Then we measure how much their light has stretched, the redshift, to see how fast they are moving away from us.
So method A predicts the speed based on the ancient past, and method B measures the speed based on the present. And they should give us the exact same number.
But they don't.
They don't.
The early universe measurement gives us an expansion rate of about 67 kilometers per second per megaparsec. The local universe measurement gives us about 73.
And that gap sounds small, but
In cosmology, it is a glaring, massive contradiction. It means either our measurements are fundamentally flawed or there's some new physics, some entirely unknown force acting on the universe that we just do not understand.
which brings us to the cosmic tiebreaker. The universe literally provided us a cheat code to figure out who is right. I'm talking about the observation of supernova SN 2025 ONI.
Oh, this was a monumental breakthrough. So SN 2025 Corny is a dying star that exploded 10 billion years ago. The light from this massive explosion has been traveling toward us for most of the history of the universe, but along the way, something incredible happened.
It hit a speed bump.
Basically, yeah. The light passed very close to a massive foreground galaxy.
And because that foreground galaxy has such immense gravity, it warped the physical fabric of space-time around it.
Exactly. General relativity tells us that massive objects curve space-time. So when the light from that distant supernova hit that curved region, it didn't travel in a straight line. It acted like a lens. The gravity literally bent the light, splitting it into multiple distinct images.
So when we looked through our telescopes, we didn't see one supernova.
We saw 4 different images of the exact same explosion, arranged like a cross.
But here's the genius part of this. Because the light took 4 different curved paths around that massive galaxy, and those paths are slightly different lengths, the light doesn't arrive at Earth at the exact same time, right?
You've hit the nail on the head. Imagine 4 runners taking slightly different curved tracks around a mountain. They all start at the same time, the explosion, but they reach the finish line on Earth days or even months apart.
Wow.
By meticulously measuring the exact time delay between when these 4 images flare up and fade away, we can calculate the precise geometric distance the light traveled.
And from that, we get a direct, undeniable measurement of the universe's expansion rate, completely bypassing all the problems with method A and method B.
And the results from that gravitational lensing are leaning heavily toward the faster expansion rate.
The 73.
Yeah. The walls of the hallway are sprinting away from us. It is stripping away the illusion of the night sky, showing us the true underlying distribution of matter and confirming that the fabric of reality is stretching toward a cold, absolute emptiness.
What really gets me about this is the implication that dark energy might not just be a constant. What if it's a dynamic field that is actively growing stronger over time?
That is the nightmare scenario.
It leads to this creeping realization that you, the listener, looking up at a sky full of stars, are enjoying a temporary privilege. Eventually, dark energy will push every single galaxy outside of our local group over the cosmic horizon. They will be moving away from us faster than the speed of light.
That the light from those galaxies will never be able to reach Earth. Any future civilization that evolves billions of years from now and looks up into the night sky will see nothing but absolute pitch black darkness.
They won't see a universe of galaxies.
No, they will have no physical way of knowing the rest of the universe ever existed. Cosmology as a science will be literally impossible.
That is just deeply tragic. But while dark energy is driving the outer walls of the universe away, the physical structure that we are bound to is moving with a terrifying momentum. We're caught in a cosmic watershed.
Yes.
Let's really look at this mechanism, because the idea of a watershed totally changes how you picture your place in space. We aren't just sitting still while the universe expands around us.
Far from it. If you look at a map of Earth, a watershed or a drainage basin is an area of land where all flowing surface water converges to a single point.
Like rivers.
Right. Every drop of rain that falls in the Mississippi River Basin eventually flows down into the Gulf of Mexico. Gravity dictates the flow. The universe operates on the exact same fluid dynamics, but instead of water, the fluid is made of entire galaxies, and instead of elevation, it's gravitational potential.
So our galaxy, the Milky Way, is just a tiny drop of water in a massive structure called the Laniakea supercluster.
Laniakea is immense. It spans 520 million light years across and contains roughly 100,000 galaxies, and every single one of those galaxies is flowing. We are being dragged at 600 kilometers per second through the cold dark of space.
I mean, if you are driving on the highway listening to this, you are moving at maybe 100 kilometers an hour. Our entire planet, our sun, our whole solar system is being hauled through space at 600 kilometers a second. You can't even process that speed.
You really can't.
It's like we are a single leaf floating on a dark, massive river at night. You can feel the current pulling you relentlessly in one direction, but you can't see the waterfall ahead.
And the reason we can't see the waterfall is incredibly frustrating. We are being pulled toward a gravitational anomaly known as the Great Attractor. It has the mass of tens of thousands of Milky Way galaxies combined.
Just a monster.
But it is hidden perfectly behind what is called the zone of avoidance.
The zone of avoidance. Just the name itself sounds like a warning label on the universe. What exactly is it?
It's the dusty, dense plane of our own Milky Way galaxy. Imagine you are standing in a thick, smoky room trying to look out the window. The gas, the dust, the billions of stars and the flat disk of our own home block our optical view of what lies beyond it.
We are blinded by the structure of our own galaxy.
Exactly. For decades, the Great Attractor was a total mystery because we literally could not see what we were falling toward.
But we eventually found a way to peer through the smoke.
We did. We had to switch from optical light to X-rays and radio waves, which can penetrate the galactic dust. When we finally mapped the region behind the zone of avoidance, we found the Norma cluster, a massive, incredibly dense cluster of matter at the heart of this Great Attractor.
So we finally found the bottom of the basin.
Or so we thought, because mapping the cosmos at this scale revealed that Laniakea itself is just a subbasin. The Great Attractor isn't the final destination.
Wait, there's more.
It's just a local node, a temporary pooling of gravity. The larger flow is dragging all of Laniakea, all 100,000 galaxies, toward an even more massive structure 600 million light years away, called the Shapley concentration.
So our home in the universe isn't a fixed set of coordinates. The boundaries of our supercluster are not defined by walls. They are defined entirely by where gravity dictates we must fall.
We have zero control over our trajectory.
We're just caught in the current.
We are flowing down a cosmic slope. But as we mapped these velocities, we discovered another force at work, and it is arguably much more unsettling than being pulled by massive objects.
You are talking about the push of the abyss, the dipole repeller.
Exactly. For a long time, astrophysics assumed our motion of 600 kilometers per second was entirely dictated by the gravitational pull of dense regions like the Shapley concentration. Gravity pulls, that is the rule.
Right. Heavy things pull lighter things.
But when a highly detailed 3D velocity field of our local universe was created, a terrifying symmetry was found. On the exact opposite side of the sky from where we are being pulled, there is a vast, incredibly empty void. A region of space practically devoid of any galaxies. This is the dipole repeller.
And it's not just sitting there being empty, right? It is actively exerting a repulsive force on us. I need you to explain the mechanics of how literally nothing can push something.
It comes back to the fluid dynamics of the cosmos. In a universe uniformly filled with matter, the gravitational pull from all directions would cancel out and you wouldn't move.
Like a tug of war where everyone is equally strong.
Exactly. But the universe is lumpy. When you have a massive concentration of matter in one direction, it pulls you. But conversely, a severe lack of mass in the opposite direction acts as a repeller. The matter surrounding the void has a stronger gravitational pull than the void itself.
Okay, I guess, yeah.
So matter flows away from the underdense regions and toward the overdense regions. The void essentially creates a negative gravitational gradient.
And the influence of this massive void pushing us is comparable in strength to the gravitational pull of the Shapley concentration pulling us.
It is. The empty spaces are not passive backgrounds. They are active, powerful participants in our trajectory. They are literally driving us out.
I had a massive epiphany when I was reading about this. It's one thing to be pulled by a massive object. Gravity makes intuitive sense to us. But the realization that nothingness itself, an absolute desolate void, is forcefully pushing us away. It is deeply unnerving.
Very eerie.
It perfectly mirrors our existential dread. If you ever feel isolated in the cosmos, the astrophysical reality is that the universe is physically structured to consolidate that isolation. The void is literally rejecting us. It is sweeping matter away from the empty spaces, ensuring the dark stays dark.
It creates a stark, segmented universe. Walled cities of light separated by vast, hostile oceans of aggressive nothingness.
But if the voids are pushing us and the attractors are pulling us at hundreds of kilometers a second, what is actually holding our specific city of light together? Why doesn't the Milky Way just fly apart as it races down this cosmic river?
This is where we get into the ghost architecture.
Of dark matter.
Everything you can see, the stars, the planets, the glowing gas, your own body, is just a tiny, almost irrelevant fraction of what exists. Normal matter is just the decorative dust clinging to the structural beams of reality.
It's just the dust.
27% of the universe is made of dark matter. It doesn't interact with electromagnetism. It doesn't reflect, emit, or absorb light. You cannot touch it. But its immense gravitational grip is the invisible scaffolding that keeps galaxies intact.
I get this deep sense of vertigo thinking about this.
Yeah.
We are sitting on an invisible chair. We think the solid world is the default, but actually the solid, observable world is a rare anomaly in a universe made largely of ghosts. How does this invisible structure actually work?
Well, for a long time, the standard model of cosmology assumed dark matter was cold and inert. It was just heavy, invisible particles sitting there in a massive halo, providing the gravity needed to keep the outer stars of a galaxy from flying off into deep space.
Like invisible glue.
Right. But new, highly detailed models of the Milky Way's core are showing that these ghosts are far more active than we thought. We are looking at a paradigm shift called excited dark matter, or XDM.
Wait, I need to stop you there. I understand normal matter getting excited. An electron absorbs a photon of light, it gains energy, and it jumps to a higher orbit. But dark matter is dark. It completely ignores light and electromagnetism. How on earth is it absorbing energy to become excited?
That is the crucial question. If dark matter doesn't interact with electromagnetism, how does it interact at all? The XDM model proposes the existence of a dark sector.
A dark sector.
Just as normal matter has forces like electromagnetism, dark matter might have its own hidden forces, dark forces that only act on dark matter particles. Deep in the chaotic, high-velocity center of our galaxy, the density of dark matter is extreme. The particles are swirling at immense speeds and they begin to collide.
And during these collisions, they are interacting via these hidden dark sector forces.
Exactly. When two dark matter particles smash together at high velocities, they exchange momentum and energy through these dark forces. The collision gives them enough energy to jump into an excited, heavier state. But just like an excited electron, this state is unstable.
They can't hold that energy forever.
Right. Eventually, they drop back down to their ground state.
And when they drop down, they have to release that stored energy. But how do we see it if it's all happening in the dark sector?
Because the energy is released as a particle that does interact with our world, specifically an electron and a positron.
And a positron is the antimatter equivalent of an electron.
Yes.
Antimatter being created by invisible ghost particles colliding.
Yes. And when those dark matter-generated positrons shoot out into the normal matter of the galactic core, they inevitably hit normal electrons. When matter and antimatter meet, they annihilate each other instantly, converting their mass entirely into energy.
The 511 kilo-electron-volt emission line.
That's it. It creates a highly specific flash of gamma rays.
And we've actually seen this.
We have been observing this massive, inexplicable spike of 511 keV gamma rays emanating from the center of our galaxy for years. Normal astrophysics models, like supermassive black hole activity or dying stars, completely failed to explain the sheer volume, the spherical shape, and the distribution of this signal.
But excited dark matter explains it.
Perfectly. It also accounts for the 2 mega electron volt gamma ray excess that tracks alongside it, and the strangely high ionization levels observed in the central molecular zone of the Milky Way.
If you're listening to this, just pause and think about what that means. Right in the center of our own galaxy, there is a massive shadow world operating completely parallel to ours. Invisible particles colliding, shooting out antimatter, creating massive energy signatures, and we are just completely oblivious to it.
Entirely oblivious.
It's like living in a house where the walls are entirely hollow and there's a massive invisible machine whirring away inside the drywall. And you can only detect it by putting your hand to the wall and feeling the faint heat it gives off.
That is exactly what it is like. We are living inside the machine. And the fragility of this invisible architecture is suddenly becoming very apparent.
Fragility.
Yeah. We used to think that a galaxy and its dark matter halo were permanently fused together. You couldn't have one without the other. But we have recently found galaxies like NGC 10052DF9 that are entirely missing their dark matter.
How do you lose your dark matter? How does the invisible scaffolding just vanish?
Through an event of incomprehensible violence. The bullet dwarf collision theory explains the mechanics of how you can separate the ghost from the machine. Imagine 2 gas-rich dwarf galaxies hurtling toward each other at massive speeds.
Okay.
A galaxy is mostly empty space, so the stars themselves rarely hit each other, but the vast clouds of interstellar gas do.
So when the galaxies collide, the normal matter crashes together like 2 cars hitting head-on.
Right. The gas clouds slam into each other, the immense friction slows them down drastically, they compress, and the shockwaves ignite massive, chaotic waves of new star formation. The normal matter is mangled in the wreck. But what about the dark matter?
Because it doesn't interact with electromagnetism, it doesn't experience friction.
Precisely. The dark matter halos of the 2 galaxies don't feel the collision at all. They only interact via gravity. So while the normal gas is slammed to a halt by friction, the dark matter ghosts right through the collision with all its original momentum intact.
It just keeps flying forward.
Yes. The normal matter collapses into a string of new dwarf galaxies in the center of the collision zone. But the massive, invisible dark matter halos coast far away into deep space.
Leaving the galaxies naked.
Exactly. We are left with naked galaxies, islands of stars with almost no dark matter to hold them together. They are incredibly fragile, prone to being torn apart by the gravity of larger passing galaxies.
It proves that dark matter is a distinct physical substance that can be violently stripped away. Our foundation in the universe, the very thing holding our solar system in its orbit around the galactic core, is untouchable by us, yet fragile on a cosmic scale.
And this connects directly to our own feelings of cosmic insignificance. We are so fiercely protective of our physical reality, but we are just passengers on an invisible structure that we can't even perceive.
And if the scaffolding is invisible and can be stripped away, the things happening within the visible parts of the universe are just, they defy any human scale of violence. If you want to know why the universe might be silent, look at what's happening out there.
If we are mapping the dangers of this cosmic cage, we have to talk about the violent engines of the dark.
Fast radio bursts.
Yes. For years, astronomers have been detecting these mysterious signals called fast radio bursts, or FRBs. They are millisecond-long flashes of incredibly powerful radio waves erupting from deep space. For a long time, we simply did not know what was causing them. Flaring pulsars, black holes.
I remember a few years ago, the alien light sail theories were everywhere. Everyone wanted the FRBs to be the propulsion systems of massive alien spacecraft.
We always want it to be aliens because finding out we aren't alone would relieve that existential dread. But the astrophysical reality is usually far more hostile. The smoking gun for FRBs came recently when a massive burst was linked directly to a superluminous supernova. We essentially captured the birth of a magnetar.
Okay, let's break down the mechanics of a magnetar because the physics of this object are absolutely absurd. We are talking about the core of a massive dead star that has collapsed in on itself.
Right.
The remaining mass, which is heavier than our entire sun, is crushed down into a sphere roughly 10 miles wide. It is the size of a city. But it is spinning at a rate of 1,000 times a second.
1,000 full rotations per second for an object that massive. The centrifugal forces alone should tear it apart, but the immense gravity holds it together. And because of that extreme spin and the ultra-dense compression of its core, it generates a magnetic field 100 to 1,000 times stronger than a normal pulsar.
We're talking about magnetic field strengths reaching 10 to the 15th power gas.
It's staggering.
To put that in perspective, if a magnetar were located halfway between the Earth and the Moon, its magnetic field would be strong enough to instantly wipe the magnetic stripe off every single credit card on the planet. And it would scramble the atomic structure of your body from hundreds of thousands of miles away.
It doesn't just destroy data, it warps reality itself. General relativity dictates that a massive spinning object doesn't just spin in space, it drags space with it.
Frame dragging. I like to think of it like dropping a spinning bowling ball into a vat of thick honey. The honey right next to the ball doesn't just sit perfectly still while the ball spins. The friction of the ball forces the syrup to physically rotate and twist along with it. In this case, space-time itself is the honey.
That is the exact mechanism of lens-throwing precession. The magnetar is spinning so furiously and is so incredibly dense that it twists the physical fabric of reality into a violent whirlpool. Now, as this newborn magnetar sits in the center of the supernova debris, it feeds on the material falling back into it.
Forming an accretion disk?
Yes, a swirling accretion disk around the equator of the magnetar.
But because space-time itself is being violently twisted into a whirlpool, that accretion disk can't sit flat.
No, it becomes severely misaligned. The twisted space-time forces the disk to wobble aggressively, like a spinning top losing its momentum. And as it wobbles, the thick material of the disk periodically blocks and reflects the intense radiation erupting from the magnetar's poles.
So it acts like a cosmic lighthouse, sweeping beams of unimaginable energy across the universe.
Precisely. And as the inner edge of that accretion disk falls closer and closer to the surface of the magnetar, the physics demand that the wobble speeds up. The pulses of light and radio waves get faster and faster, closer together.
Like a chirp.
Exactly. When the FRB signal was analyzed, this exact mathematical pattern was observed, a high-frequency chirp in the light curve. It was the definitive mechanical proof that a wobbling magnetar accretion disk was powering these massive bursts.
And the terrifying part of this discovery is that we are realizing these ticking time bombs don't just form in young, violent galaxies where giant stars are dying. We are finding evidence that magnetars can form from the collision of old, dead white dwarfs.
White dwarfs are the quiet, smoldering embers of sun-like stars. They can orbit each other peacefully in the dark for billions of years. But eventually, orbital decay brings them together. When they merge, the sudden influx of mass and rotational energy can spontaneously birth a magnetar out of thin air.
Think about what that means for the Great Filter. You could have a quiet, ancient solar system. A civilization evolves. Maybe they colonize their local planets. There are no massive, dangerous stars anywhere near them. Just old, dead remnants floating in the dark.
And then two of those invisible remnants merge.
And suddenly, in a fraction of a millisecond, a city-sized object flares to life with enough magnetic and radiation power to sterilize anything within light years. The universe isn't a peaceful, empty backdrop. It is heavily mined.
It is a fundamentally hostile environment. It makes total sense why we are so incredibly desperate to find someone else out there. We are sitting in this dark, violent room, completely isolated, and we just want to know if anyone else is alive.
Which leads us directly to our desperate search for a mirror. I want to talk about K2-18b because it perfectly encapsulates the psychological desperation of our current scientific era.
It really does.
Because those magnetars make the universe a literal minefield, the odds of a civilization surviving long enough to build a radio are drastically reduced. That desperation is why we are currently staring at a tiny planet 120 light years away, hoping against hope that a faint chemical whisper is life.
So K2-18b is a sub-Neptune exoplanet. It is roughly 2.6 times the radius of Earth and about 8.6 times the mass. Astronomically, sub-Neptunes are fascinating because our statistical surveys show they are the most common type of planet in the entire Milky Way galaxy.
Yet, ironically, we don't have a single one in our own solar system. We have small rocky worlds like Earth and Mars, and we have massive gas giants like Jupiter and Neptune. But the most common type of planet in the universe is completely absent from our backyard.
It's a profound blind spot in our planetary models. So, naturally, when the James Webb Space Telescope became operational, K2-18b was a prime target. The telescope was pointed at it, analyzing the starlight filtering through the planet's atmosphere to see what chemicals were present. The initial data was incredibly tantalizing. Strong absorption lines for methane and carbon dioxide were found.
Which is a great start.
It is. But then a tiny anomaly was noticed in the spectrum. the faint spectral whisper of a molecule called dimethyl sulfide, or DMS.
Explain why the astronomy community collectively held its breath when they saw DMS. Why is that specific molecule so important?
Because DMS is a highly specific biosignature. On Earth, dimethyl sulfide is almost exclusively produced by biological life. Specifically, it is a byproduct of marine phytoplankton metabolizing in our oceans.
It's the chemical that gives the ocean its distinct sea smell.
Exactly. When the signature of DMS was detected on an alien world, the immediate euphoric hypothesis was that K218b might be a Haitian world.
A Haitian world, combination of hydrogen and ocean.
Yes, a theoretical type of planet completely covered in a vast, incredibly deep, global liquid water ocean, wrapped in a thick, insulating, hydrogen-rich atmosphere.
The psychological weight of that idea is massive. To look out into the violent, terrifying cosmos we just described, full of expanding voids, crushing gravity, and magnetar blenders, and see a blue marble, an ocean world making the exact same chemical produced by living organisms on Earth. It feels like a lifeline.
It does.
It means maybe the pass filter isn't so rare after all.
It feels like a lifeline, yes. But, unfortunately, that lifeline is currently dangling over an abyss of rigorous scientific skepticism. The reality of the data is brutal. The DMS signal was measured at what physicists call a 3 sigma levels of significance.
Break down 3 sigma for us. What does that actually mean in terms of certainty?
In statistics, sigma measures standard deviations from the norm. A 3 sigma result means there is roughly a 99.7% chance the signal is real, and not just random background noise.
In everyday life, that sounds like a sure thing.
It does, but in particle physics and high-stakes astronomy, a 3 sigma signal is just an interesting blip. It is a hint. To claim a definitive, unquestionable discovery, the scientific standard is 5 sigma, a 1 in 3.5 million chance of being a fluke.
So the signal is statistically weak.
It is weak, and the chemistry models make it even worse. Subsequent atmospheric modeling has shown that under the specific temperature and pressure conditions of a hydrogen-rich atmosphere, purely non-biological abiotic chemical reactions can produce gases like propyne. And propyne, tragically, has an absorption spectrum that almost perfectly mimics the exact signature of dimethyl sulfide at the resolution the telescope was using.
So the telescope might just be seeing a dead abiotic chemical reaction, and we, in our sheer desperation to not be alone, are mistaking it for alien phytoplankton.
It is entirely possible. Furthermore, new thermodynamic models of K218b suggest that the planet's thick hydrogen envelope might trap too much heat. The greenhouse effect could be runaway. The planet might not be a cool, blue, life-harboring ocean world. The pressure and temperature at the surface could be so extreme that the ocean is entirely composed of boiling supercritical magma.
We are staring into what we hope is a mirror, looking for another Earth. And we might actually be staring directly into a high-pressure molten furnace. This brings us crashing violently back into the past filter.
Yeah, it really does.
If K218b is dead, and if the thousands of other exoplanets we are scanning turn out to be dead, the weight of the cosmic silence grows exponentially. It strongly reinforces the terrifying idea that abiogenesis, the actual spark of life from dead chemistry, is an impossibly rare fluke in the universe.
We might truly be the anomaly, and if we really are an impossibly rare biological fluke, an accident of chemistry and a hostile void, you have to ask a much deeper question. What is the fundamental nature of the physical reality we occupy?
Because if you look closely at the physics of our universe, if you zoom down past the massive cosmic watersheds and the dark matter halos, and you look at the fundamental building blocks, reality breaks down into something that feels deeply unnatural.
We have to talk about the second quantum revolution.
Yes, because the rules of the universe are starting to look like glitching code.
For a century, we operated under a strict dichotomy. We believed that the bizarre, mind-bending rules of quantum mechanics, things existing in multiple states at once, particles teleporting through solid barriers, instantaneous entanglement, were strictly confined to the microscopic world, subatomic particles.
Right.
But the macroscopic world, the world of baseballs and planets, was governed by the strict, predictable rules of classical Newtonian physics. But that boundary between the quantum and the classical is completely collapsing.
The levitating time crystals. When I read about this, my brain fundamentally rejected the information. It sounds like science fiction magic. Walk us through the mechanics of what a time crystal is and how it was created.
It is profoundly counterintuitive. A macroscopic system was created using millimeter-scale styrofoam beads. These aren't invisible subatomic particles. They are objects you can hold in your hand. They placed these beads into an acoustic levitator.
An acoustic levitator. Literally using the physical force of highly focused sound waves to hold an object suspended in midair.
Exactly. The sound waves create a standing wave, a cushion of pressure that traps the beads. But here's where reality bends. Beads of slightly different sizes were introduced. Because the sound wave scattered differently off a larger bead than a smaller one, the aerodynamic forces interacting between the beads become non-reciprocal.
Stop right there. Non-reciprocal forces. This breaks Newton's third law of motion, right? Newton's third law is the absolute bedrock of physical reality. For every action, there's an equal and opposite reaction. You push a wall, the wall pushes back with the exact same force.
That is how the universe is supposed to work. But in this levitating system, the acoustic scattering breaks that fundamental symmetry. Bead A exerts a certain aerodynamic force on bead B, but bead B does not exert an equal and opposite force back on bead A. The forces are imbalanced.
That's insane.
Because of this continuous non-reciprocal interaction, the entire cluster of macroscopic beads spontaneously begins to oscillate. They start dancing in a repeating, complex rhythm.
And they are doing this without any external motor or pendulum or timer driving them?
They are holding their macroscopic order together purely through broken symmetry. It is a time crystal, a structure that repeats not in space, like a diamond lattice, but repeats strictly in time, existing in a permanent state of oscillation without losing energy. We are witnessing macroscopic objects defying classical physics in the palm of a hand.
And it's not just time crystals. We're seeing quantum tunneling scaled up too.
Yes. Quantum tunneling is usually when a single electron occasionally pops through an impenetrable energy barrier. It's a statistical anomaly. But recently, macroscopic quantum tunneling was observed. Billions of electron pairs, known as Cooper pairs, in a superconductor, tunneling through a solid physical barrier at the exact same time.
Billions of them. It's not just one subatomic particle rolling the dice and magically appearing on the other side of a wall. It's a massive coordinated jump of macroscopic matter.
It breaks the intuitive rules.
If physical reality can bend its own fundamental rules like this, if macroscopic objects can defy Newton, and solid matter is just an illusion of non-reciprocal forces, then what is the mind? What is the consciousness that is observing all of this glitching physics?
That is the hard problem of consciousness. And right now, the two leading neurological models in the world are fighting a massive adversarial war over it. On one side, you have integrated information theory, or IIT.
How did IIT define consciousness? Because it throws out a lot of the mystical biological ideas we have about the soul.
IIT proposes that consciousness isn't a magical ghost in the machine. It isn't even strictly tied to human biology. IIT argues that consciousness is simply a mathematical value. It is a fundamental property of how a system's causal structure integrates information. They quantify this integration with a mathematical value called phi. If a system, any system, biological or artificial, has a high enough phi, it is conscious. In humans, high phi seems to track to the posterior hot zone in the parietal and occipital cortex of the brain.
So under IIT, consciousness is just math. It's the shape and density of data processing.
Exactly. But the rival theory, Global Neuronal Workspace, or GNW, completely disagrees. GNW says consciousness is an emergent property of information broadcasting. It argues that processing data in isolated regions of the brain is unconscious.
So when do you become conscious?
You only experience consciousness when a specific piece of data is globally shared across the brain's wide-scale network, primarily involving the prefrontal cortex. Consciousness is just the sudden ignition and global broadcast of data.
This unnerves me deeply. Think about the implications. If consciousness is just the flow of information or a mathematical value of integration, and physical reality is just a set of non-reciprocal quantum rules that can be bent and broken, it breathes terrifying new life into the simulation hypothesis.
It absolutely does. For a long time, it was argued that the simulation hypothesis was a fun philosophical thought experiment, but physically impossible because of computational limits. The argument was that to render the entire universe down to the Planck length, to calculate the exact quantum state of every single atom in every single star in Laniakea, would require a computer larger than the universe itself.
The energy requirements would be infinite.
Right. But if IIT or GNW is correct, a simulator wouldn't need to render the physical universe at all. They would only need to render you.
Yes. This is the philosopher Nick Bostrom's brilliant counter-argument. A highly advanced simulator doesn't need to waste processing power, rendering the background radiation of a distant galaxy, or the internal structure of dark matter halos. It only renders subjective experience. If consciousness is literally just a value of phi, or a global broadcast of data, then a machine just needs to input the algorithm of your sensory data. It inputs the math of my dread. It inputs the math of my profound loneliness when I look at a faked simulated telescope image of K2-18b.
It's highly efficient.
Our profound isolation in the cosmos might not be a physical reality at all. The voids might not be real. The great silence might just be a variable in an algorithm, designed to see how a simulated neural network reacts to total isolation.
We might be solitary minds trapped in an algorithmic void.
Which brings us to the most horrifying dark irony of this entire exploration. If we are so deeply terrified that we might be biological computers trapped in a cold, unfeeling simulation, what is our response? We start building actual computers out of our own biology.
We are crossing the threshold into the biological singularity. For decades, we have relied on silicon to build artificial intelligence. But we are hitting the absolute physical and thermodynamic limits of silicon-based AI. The massive data centers required to train large language models are consuming the power output of entire small countries.
The power grids can barely handle the megawatts required.
But the human brain, it operates on about 20 watts of power, a fraction of a light bulb. It is 1,000,000 times more energy efficient than our best supercomputers.
So the tech industry looked at that efficiency and decided to harvest it. We are entering the era of organoid intelligence, or OI. Explain the mechanics of this, because it sounds like a dystopian horror movie. How do you plug biology into a server rack?
It starts with stem cells. Human stem cells are coaxed to grow into three-dimensional clusters of neural tissue in a laboratory dish. These are called brain organoids. Once they have a dense network of living, firing human neurons, they interface them with computers using high-density microelectrode arrays.
The bridge between the wet biology and the digital silicon.
Yes. The microelectrode arrays sit underneath the neural tissue. They can detect the minute electrical voltage spikes, the action potentials generated by the human brain cells when they fire. And conversely, the array can send specific electrical pulses into the tissue to stimulate the neurons.
A closed loop.
It creates a closed-loop system. The digital computer sends sensory data in via electrical pulses, the biological brain processes it, and the computer reads the electrical output as a decision.
And this isn't theoretical. Companies are doing this right now.
Final Spark has already launched the Neuro platform. It is the world's first biocomputing cloud platform. It literally allows remote researchers to run AI operations on living human neurons sitting in a lab via an internet connection.
The cloud is made of human brain cells.
And Cortical Labs took it a step further with their CL1 bioprocessor. They proved the learning capability of this concept with a project called DishBrain. They took 800,000 living human brain cells, hooked them up to this microelectrode array, and fed them the electrical input of a simulated environment. They taught the human brain cells to play the video game Pong.
And the terrifying part is how fast they learned. Traditional silicon AI, using reinforcement learning, takes over 90 minutes of brute force computational training to understand how to hit the ball in Pong.
The human brain cells adapted and learned the game in 5 minutes. Their neural plasticity allowed them to wire themselves for the task almost instantly to achieve a predictable electrical state.
But think about the ethical nightmare we are creating here. 800,000 brain cells is roughly approaching the neural density of a bumblebee. At what point does that cluster of human neurons wake up?
That is the crisis of embedded ethics. It ties directly back to integrated information theory. If consciousness is just integrated information phi, then by growing these organoids larger and networking multiple clusters together to solve complex AI problems, we are rapidly increasing their phi. The math dictates that they might develop rudimentary consciousness.
They might have a subjective experience of the world.
Exactly, and because they are wired to seek predictable states to win the game to stabilize their environment, they might feel the biological equivalent of stress, anxiety, or pain when they fail a task. We are literally creating isolated, trapped consciousnesses in our laboratories, forcing them to solve our math problems and play video games in the dark.
It is the ultimate manifestation of existential isolation. We look up at the stars, we see the dark energy pulling the walls away, we see the voids pushing us, and we feel alone and trapped in a cold, cosmic cage. And our response to that trauma is to grow a human brain in a dish, trap it in a silicon box, and force it to be as lonely as we are.
All while we desperately try to engineer our own bodies to avoid death entirely. The pursuit of radical longevity is the exact other side of this biological hubris. We are terrified of our cosmic frailty.
We want to live long enough to beat the filter.
Yes. The discovery of Yamanaka factors was the turning point. It was found that by exposing adult cells to specific proteins, the cell's memory could essentially be wiped. An aged, damaged adult cell could be epigenetically reprogrammed back into a youthful, flexible stem cell state.
It is cellular time travel.
And now, this process is being accelerated using the very AI systems we are building. A specialized AI model, GPT-4b Micro, was recently used to design entirely new synthetic variants of these reprogramming factors.
We are using silicon AI to rewrite human DNA, while using human brain cells to run AI. And this longevity research isn't just theory anymore.
It has entered human trials. The ER100 trial is currently underway. These synthetic AI-designed reprogramming factors are being injected directly into human optic nerves. The goal is to reverse cellular aging and restore vision lost to glaucoma or age. We are actively trying to erase the boundary line between human and machine, between aging and immortality.
We are stripping our brain cells to build immortal computers, and we are using computers to rewrite our biology to make our bodies immortal. But this immense, accelerating technological hubris brings us directly face-to-face with the end of the line, the future filter.
Everything we have discussed today converges right here. If the past filter is not the answer, if the chemistry of life and complex cells are relatively common in the universe, then the great silence is not an empty room. It is an obituary.
It means the filter is a trap waiting for us.
It means that every single civilization that reaches our current level of technological mastery dies. They cross a line and they are extinguished. They never transition into what is called a Grabby civilization.
Explain the Grabby Aliens model. Because if a civilization survives, it shouldn't be quiet.
The Grabby Aliens model is pure statistical logic. If a technologically advanced civilization survives its infancy, it will inevitably expand. It will expand outward at a fraction of the speed of light, colonizing neighboring star systems. And as it expands, it will manipulate its environment on a massive scale.
Dyson spheres.
It will build Dyson spheres around stars to harvest their energy. It will engineer stellar structures. It will become Grabby, consuming space and resources.
And a Grabby civilization would be blindingly obvious to us. If they were out there, our telescopes would see the unnatural dimming of stars or the massive infrared heat signatures of their megastructures.
Exactly. The fact that we don't see any Grabby civilizations means no one makes it out of the cradle. The future filter stopped them all. Why? The traditional theories point to technological suicide. A civilization invents artificial general intelligence, fails to align the AI's goals with biological survival, and the AI neutralizes the creators in a matter of hours. Or a civilization unlocks limitless energy, weaponizes it, and dies in a planetary nuclear annihilation.
Those are the loud, explosive ends.
Yeah.
But there is a newer, much more haunting theory for the future filter. The idea that civilizations don't end in a bang, they end in a whisper. Terminal depopulation.
The quiet apocalypse.
Yes, break down the mechanics of terminal depopulation because it looks exactly like what human society is doing right now.
The demographic data tells a chilling story. As a civilization advances technologically, several things happen simultaneously. Education drastically increases. Wealth and comfort increase. Infant mortality plummets. But most importantly, advanced biotechnology allows for the complete decoupling of sex from reproduction.
Right.
Having children becomes a conscious, highly demanding choice rather than a biological inevitability.
And as a result, the total fertility rate, the TFR, plummets.
It crashes. For a population to simply maintain its current numbers, you need a replacement level TFR of 2.1 children per woman. Across the developed world right now, we are seeing TFRs crash well below 2.1. In some advanced technological nations, it is falling below 1.0.
Below 1.0.
The math of exponential decay is brutal. If your fertility rate stays below 1.0, your population halves every generation.
So the civilization doesn't explode, you just fade away. The civilization gets incredibly comfortable. They are highly entertained by perfectly tailored simulated realities. They are biologically long-lived, thanks to Yamanaka epigenetic reprogramming. They can live for centuries in perfect health. And because life is so long and comfortable and self-contained, they just quietly stop having children.
The drive to reproduce is smothered by extreme technological comfort. The last generation lives out their extended, immortal lifespans in a flawless virtual reality, or perhaps they upload their consciousness into those biological server racks we discussed. And then thousands of years later, when the last physical hardware degrades, the lights just quietly go out. A silent extinction.
It is a profoundly depressing solution to the Fermi paradox.
Yeah.
And it is exactly why the search for past life is so fraught with absolute terror. The bad news argument states that if we send a probe to Mars or drill through the ice on Europa, or if the Space Telescope looks closely at the atmosphere of K2-18b and we definitively find the ruins of a complex biological ecosystem, it would be the final, undeniable proof.
It would prove that the past filter was easy. Life started everywhere. Which means the reason the universe is silent is because the future filter is an insurmountable wall. We would know with mathematical certainty that our doom is waiting for us just over the technological horizon.
It's like walking into a pristine, sealed room, finding everyone dead on the floor from a silent, odorless poison gas, and realizing you just took a deep breath.
We are floating in a cosmic watershed, dragged blindly at 600 kilometers a second toward a massive gravitational anomaly we can't even clearly see through the dust of our own home. We are being actively pushed away by vast, desolate voids that mirror our isolation.
The ghost architecture.
The very scaffolding of our galaxy is made of invisible ghost particles colliding in the dark. We are surrounded by dead stars spinning so fast they drag the physical fabric of reality into blenders. We are playing God with our own isolated human brain cells, forcing them to suffer in silicon boxes, all while walking blindly toward a potential future filter that has quietly murdered every other civilization in the cosmos.
It places an overwhelming, crushing weight of responsibility squarely on your shoulders, on our shoulders. Because if we are the only ones, if the filter is behind us, and we are the 1 in a billion statistical miracle of eukaryogenesis and a stable moon, then we are the universe's only way of knowing itself.
That is the ultimate burden.
The atoms in your body were forged in the cores of dying stars, and through billions of years of random chance, they organized themselves into a biological structure capable of looking back up at the sky and feeling awe. We are the cosmos experiencing itself. If we fail, if we hit the future filter and succumb to depopulation or rogue AI, the universe doesn't just go back to being quiet.
It goes back to being truly permanently dead. An unimaginably vast machine expanding into the dark with absolutely no one left to observe it. The burden of survival isn't just about human continuation. It is about maintaining the only spark of comprehension in an incredibly dark, stretching canvas.
I want to turn this over to you, listening right now. We have covered a massive amount of terrifying ground today. Which of these cosmic horrors actually keeps you awake at night? Is it the invisible dark matter scaffolding holding us captive, the massive dipole void actively pushing us into isolation? Or is it the terrifying trap of the future filter, waiting to quietly extinguish us through our own hubris? Leave a comment below and tell us what mechanism you want us to explore further in our next session. Because navigating this cosmic minefield requires all of us paying attention to the reality of our situation.
We have to map the exact dimensions of this cage if we ever want to survive it.
And I want to leave you with one last heavy realization to carry with you today. Think back to that silent ancient forest we started with. We assume the silence of the universe is just an empty, pristine wilderness waiting to be explored. But the math and the physics and the great filter suggest something much darker. The silence of the universe might not be an empty forest at all. It might be a sprawling, infinite graveyard. And right now, we are the only ones left holding a shovel.